Welcome to another video about statistics. In this video we're going to talk about describing and exploring and comparing data. Basically we're going to begin the numerical analysis of a data set. We're going to see different kinds of measurements of center and different kinds of measures of variation. First we're going to talk about the measurements of center. We have several different kinds. We have the mean, which is basically the average of the data. For the mean, there are two different kinds of mean. There's the population mean and the sample mean. For the population mean, you'll see this Greek symbol mu. So this is the mean of an entire population, so they use a different symbol. Whereas the sample mean, they refer to it as x bar. Typically in the formulas you'll be seeing sample mean, just because collecting the population mean is labor intensive, and the whole point of statistics is to work smarter, not harder. The next type would be the median, which is simply the midpoint of the data. So first you would need to arrange the data points from least to greatest, and then you would find the most middle data point. If there are two data points there in the middle, you would simply take the average of those two data points. The mode is the most frequent data point. So if there's any data points that repeat, that would be considered the mode. There's such thing as unimodal, which means there's only one mode, which means there's one data point that repeats several times. There's bimodal, which means there's two separate data points that have the same repetitions. And there's also an idea of no mode, which means none of the data points repeat. And last but not least, there's mid-range. Mid-range is the largest value added to the smallest value and then divided by 2. We have these different types of measure because sometimes one measure of center is not as accurate as you would like it to be. For example, if there is an outlier in our data set, where an outlier is a data point that is much larger or smaller than the rest of the data, this outlier can greatly affect the mean. So if we have a mean of a traditional data set and you throw in an outlier, that outlier can drastically increase the mean or decrease the mean depending on the type of outlier. So if an outlier exists, the mean would be not as accurate as you'd want. If the outlier exists, a more appropriate measure of center would be the median, because the median would basically describe the center behavior of the data. Another descriptor of statistics would be the measures of variation. And variation basically describes the spread of the data. Okay, so a large variation means that there is a large spread of data. That means from the smallest to the largest data set or data point, there is a big difference. A small variation means a small spread of data. Okay, there's three types of variation. There's the range, standard deviation, and the variance. The range is simply the largest value minus the smallest value. Standard deviation is the average spread of the data, and variance is the standard deviation squared. Standard deviation has also two different variables. There's the population standard deviation, which can be found using this formula. This is saying the summation of our data point minus our mean squared divided by our population size. Again, this is one of the situations where this is used for the population. So we typically don't find the analysis of the whole population because it's labor intensive and difficult. More typically, we find the standard deviation of a sample, where the formula is almost exactly the same, except the only difference is we have this n minus 1 on the bottom. So instead of dividing by n, the population, we divide by n minus 1. So our divisor is a little smaller. If our divisor is smaller, that means our actual numbers can be a little bigger. So our sample spread is going to be a little more forgiving for our data set. And then last but not least, we have variance, which is our standard deviation squared. So that would be for a population, and we would have our standard deviation squared for a sample. We typically see variance later when we're doing in-depth analysis of hypothesis testing. So it's just helpful to know how we get variance, which is basically just standard deviation without that final step of taking the square root. Okay? If you want to see how to calculate standard deviation by hand, there's a separate video for that. But a lot of calculators do this for you, which eliminates a lot of human error. Another idea of comparing data deals with the empirical rule, which applies if our data set is normally distributed. So if you were to make a histogram of your data, for example, and the data resembled a bell curve in some way, doesn't have to be perfect, but if it's relatively close, you could assume the empirical rule applies, which is basically if you were to arrange your data, most of the data would be forming around the mean, which we refer to as x bar. So looking at x bar being in the middle, you can see that a big chunk of your data is really close to the mean, whereas a very small amount of data is far away from the mean. In fact, if we were to start at our mean and increase the spread by 1 standard deviation, so add 1 standard deviation and subtract 1 standard deviation away from our mean, we would encompass 68% of our data. So again, if we're looking at the center of our mean and we look at the window that is 1 standard deviation away from the mean, we would have 68% of our data. Same idea. If we were to increase our spread again, or increase our window to 2 standard deviations, so instead of looking at the middle of the mean, we're going to add not 1, but 2 standard deviations, and we're going to subtract not 1, but 2 standard deviations to increase our window. We would now encompass 95% of our data. Okay, so within 1 standard deviation of the mean, 68% of our data occurs. If we increase that window to 2 standard deviations of the mean, that means we are covering 95% of our data. And if we increase it even further to 3 standard deviations, which seems like it's covering basically all of our data, but in fact it is covering 99.7% of our data. So if the data set is normally distributed, 68% of the data is within 1 standard deviation of the mean, 95 is within 2 standard deviations of the mean, and 99.7 is within 3 standard deviations of the mean. Standard deviation is, again, the average spread of our data. So if we increase our spread, we'll cover most of our data, or almost all. Another view of the table, basically it's telling the same story, but in terms of standard deviation. So above, in the middle, was our mean, or in the middle, or 0 standard deviations away from the mean. So if we were to look at this table, we would say the middle would be 0. And the farther we go out, or increase our standard deviations, we would add 1 standard deviation, or subtract 1. We would add 2, or subtract 2. we would add 3 or subtract 3. Okay, so the same idea. 68% of the data is in the middle, or close to the mean, or 1 standard deviation away from the mean. 95% of the data, is within 2 standard deviations of the mean, and then 99.7% of the data is within 3 standard deviations away from the mean.